Section 9.8 is the sine and cosine ratios. I can use sine and cosine to find triangle side lengths. The sine and cosine ratios. The sine of an acute angle of a right triangle is the ratio of the length of the side opposite to the angle to the length of the hypotenuse. So if we're looking here from angle A, opposite is side A, our hypotenuse is side C, and our adjacent is side B. And for sine, we just need O and H, opposite and hypotenuse. So, the sine of an acute angle of a right triangle is the ratio of the length of the angle's adjacent side to the length of the hypotenuse. So here, again from angle A, we have adjacent, hypotenuse, and opposite. The adjacent side is part of our angle. Okay, and with cosine, we use A and H. So sine equals O over H, cosine equals A over H. So combined with tangent from section 8.7, we have Sohcahtoa. And that's how we can remember our trig ratios. Sohcahtoa, which again I have here. So Sohcahtoa, sine of our angle. This is theta here, guys. It just tells us that that's an angle. So all it's telling us is that it's an angle. Sine is opposite over hypotenuse. Sine equals opposite over hypotenuse. Cosine of our angle equals A over H. Cosine equals A over H, adjacent over hypotenuse. And tangent of our angle equals O over A. Tangent equals O over A. So Sohcahtoa is how we remember our trig ratios. In example 1 here, we're going to use triangle JKL on page 494, and I have a sketch of it here to find the sine and cosine of angle L. So from angle L here, we need to figure out our opposites, our hypotenuses, and our adjacents. So from L, the side that's part of our angle and part of our 90 degrees, that's our adjacent side. Our hypotenuse is always our longest side, and the one opposite is our opposite side, the one that's not a part of our angle. It's like the odd side out. It doesn't make the angle. Odd is our opposite. Here, when I'm looking for sine of angle L, I'm going to remember sine is opposite over hypotenuse. So I'm going to use opposite 8 over hypotenuse H, 17. For cosine of angle L, you remember A over H. So cosine of my angle L, again here we don't have a measure for it, so we just label it as L, is adjacent 15 over my hypotenuse 17. Now, feel free to pause here and give this a try if you'd like. We're going to try from angle JKL to find the sine and cosine of angle J. So from angle J here, our side lengths change a little bit. Our hypotenuse is still just our hypotenuse, but our opposite side is the 15. And our adjacent side that's part of our angle is the 8. So here for sine of angle J, we're still going to use sine equals opposite over hypotenuse. Opposite is 15. And our hypotenuse is 17. For cosine of angle J, we remember cosine equals adjacent over hypotenuse. Our adjacent is 8, and our hypotenuse again is 17. That never changes. Our hypotenuse is our hypotenuse, that longest side, no matter which angle we're looking at. In example 2, we're going to use the calculator to approximate to 4 decimal places. Here on our calculator, there's 3 buttons next to the pi key, so 4 down and then to the right, 1, 2, and 3. We already used our tangent key before, as long as you have a TI 32 line like I have up on my wall anyway. We're going to find the key that says sine now, so S-I-N. Before we did tangent, T-A-N, now we're doing sine, S-I-N. So we're going to press that key, then we're going to type in 38 and close our parenthesis. Again, make sure that our calculator's in degree mode first, which means it has DEG or a D, depending on what type of calculator you have on the display screen. And here I get 0.615661475. We want to approximate it to 4 decimal places. So I count out my places, 1, 2, 3, 4, and I look at the number following. 6 is bigger than 5, so it rounds up. 0.6157. Now cosine is in between sine and tangent. So we're going to press our cosine key. It's going to come up with a parenthesis. We type in 43 and close that parenthesis, and then press enter. And here what I get is approximately 731353702. Again, 4 decimal places, count them, 1, 2, 3, 4. We look afterwards. The 5 or higher rounds up, so it's 0.7314. And that's approximately what cosine of 43 degrees equals. Feel free to pause here and give this a try if you'd like. Use the calculator to approximate sine of 74 degrees and cosine of 12 degrees. And again, we're doing 4 decimal places. So sine of 74, we're going to press the sine key, type in 74, close your parenthesis, press enter, 0.961261696. 4 decimal places, 1, 2, 3, 4, and a 6 is 5 or higher, so it rounds up. Here we get 0.9613, approximately rounded to 4 decimal places. Cosine, again, is in between sine and tangent. We press that and then 12, close your parenthesis and enter. 0.978147601. 4 places, 1, 2, 3, 4. And 4 is less than 5, so we round down. Here, 9781. We keep it the way it is and just drop off the numbers that follow. In example 3 here, we're going to use triangle DEF on page 495 to find the value of x. So, right triangle here. We have a side. We have an angle here, 41 degrees. We need to figure out what sides we have. Well, 16 is our longest side. It's opposite of our 90-degree angle. So we know that that's our hypotenuse. And our side that is x here is the other part of our angle. It's the adjacent side, right next to the side or the angle we're looking to. So here I have an A and an H. And we know that goes with cosine. If you're not sure, write out Sohcahtoa. We need A and H, but the only one that has both is ka. So we take cosine of our angle, 41 degrees, equal to A over H. A here is just x, we don't know what it is, but H is 16, that we do. Now, our x is being divided by 16, and we want to get rid of the division. So we multiply to get rid of our division. And now we type in our calculator, 16 times cosine of 41 degrees, close your parenthesis, press enter. Here I get 12.075353228 approximately, equal to x. I'm going to round to the nearest tenth, 1 decimal place. So 1 decimal place, 7 rounds up, and it's about 12.1. Same idea here for example 4. We're going to use the triangle in example 4 on page 495 to find the value of x here. So I have an angle. From this angle, I need to figure out what my sides are. So 164 is my hypotenuse. It's opposite my 90-degree angle. It's my longest side. My x is opposite. It's not a part of my angle. it's the odd side out. It doesn't make up my angle. Okay, it's the odd side out. It's opposite of where my angle is. If I draw a line from my angle through, split it in half, I'll cut through that opposite side. So here, again, Sohcahtoa, we're looking for O and H. O and H is sine. So we're going to take sine of our angle, 27 degrees, equals, sine equals opposite over hypotenuse. Opposite is x, hypotenuse 164. I have division by my variable, so I'm going to get rid of it by multiplying. And now we go to our calculator. 164 times sine of 27 degrees. X is approximately 74.45444196. Again, here I'm going to round to the nearest tenth. It doesn't specifically say, so that's where I'm going to go. Doesn't super matter here, since it doesn't tell us one way or the other. So 5 rounds up, and x is going to be approximately 74.5. Labeled in feet because our other side was in feet, so we know what that unit is. Last thing I have here in section 9.8 is a summary of the right triangle relationships. This is also on page 496. So far this chapter we've done Pythagorean theorem, where our two side lengths, our legs, we can square, add together, and that distance should equal our hypotenuse squared, our longest side squared. We had special triangles. Here these aren't to scale, so be careful there. In a 45, 45, 90 degree, our two sides are the same, and we take that side length and multiply it by the square root of 2. In a 30, 60, 90 degree triangle, we take our short side, this is our short side, we double it to get our hypotenuse, and to get our long side, we take our short side times the square root of 3. Sine, cosine, and tangent we remember with Sohcahtoa. Sine is opposite over hypotenuse. Sine equals opposite over hypotenuse, so ca is adjacent over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Sohcahtoa. And that's all I have for section 9.8.